These are the notes on negative exponents. The biggest problem with negative exponents is you have to remember that wherever there are the most of a letter, number, any term left, that's where you have to leave your answer. Sometimes that'll be a fraction, sometimes it'll be a whole number, but when we're dealing with negative exponents, we want to try to write our numbers in terms of a positive exponent whenever possible. We talked about before that we can expand out our numbers when we're doing division or our letters, and we can cancel out what we have, and wherever the number is left, the most of them, that's where our answer goes. So if we do that here, we have b to the third over b to the fifth. If we expand that, we can see by canceling that we have b squared left on the bottom. Because there's extra b's in the denominator, the result is a fraction. We're going to have to get comfortable with using these as a fraction. If we use the quotient rule, we can see that 3 minus 5, right here, gives you negative 2. We can rewrite this as 1 over b squared. Be very careful that, right here, you rewrite that as positive. When this is negative, and we rewrite it, then it has to become positive. So the rule tells us this: for any real number b that's non-zero and any integer n, we have b to the n equals 1 over b to the n. So if this one is negative, then we switch it to 1 over positive. It's the reciprocal of what it originally was. We can think about this as being over 1, and then we can do the reciprocal, which flips this over. But let's be sure that we write it with a positive exponent when it changes places. What we're going to do, once we go through examples, we're going to have a very easy way to remember. Just ask yourself the question, does it have a positive exponent or negative exponent? If it's positive, it stays. If it's negative, it moves. What I mean by that is this: m to the negative 3. That's a negative exponent. It has to move. So it's going to go down to m to the third. And so our answer will be 1 over m to the third, and it stays in a fraction form. 4 to the negative 2. Ask yourself the question, does it have a negative exponent? Think about it as a fraction, 4 to the negative 2 over 1. It does have a negative exponent, so we're going to rewrite that as 1 over 4 squared. 4 times 4 is 16. It stays in fraction form. Wherever you get the most of a letter or number left is where we're going to write it with a positive exponent. So you can see an example with negative 3 to the negative 2 power. Keep in mind, if we have negatives in parentheses, they have to stay that way, because this is not the same thing as negative on the outside 3 squared. This is negative times negative, which gives us positive 9. So be sure that we keep in mind what we're trying to do here. Negative 3 times negative 3, and we get positive 9. Okay, sometimes we don't have everything that moves or everything that stays. This is where the question comes in. Look at the a. A to the first. It's positive. It's going to stay on top. B to the negative 1 has to move. Usually we will not write the exponents on it, so it will be a over b, which is the same thing as a to the first, b to the first. You cannot just put answers wherever you want to put them in a fraction form. You have to follow the rules. Positive exponent stays whether it's on top or bottom. Negative exponent has to move. And notice down here at the bottom, a negative exponent does not mean that the expression is negative. Okay, it's only a method for writing a fraction in a more convenient way. As a general rule, solutions do not contain negative exponents. Sometimes we have a negative exponent in the denominator. Same as we did before, we're going to rewrite as the reciprocal. So you look at your exponent, say, is it negative? If it is, it has to move. And so then we can rewrite it as x squared over 1 or simply x squared. Okay, on the back, sometimes we can use more than one rule. Here, if we have x to the 5th times x to the negative 5. If we use our original rule, if you have the same base, we add exponents. 5 plus negative 5 gives you 0, which another rule tells us x to the 0 is 1. Or, if we look at the rule of negative exponents that we just talked about, this is negative, it has to move to the bottom. We kept x to the 5 on top. Anything divided by itself equals 1. So we've got different rules that may apply, but we end up with the same result. And here's the rule that says x to the 0 power is 1. It says, in fact, any non-zero number raised to a 0 power is equal to 1. 0 to the 0 is undefined, so we don't have an answer for that one. So all these 5, 6, and 7 are all equal to 1. Okay, look at this original example here. This started out as, rewrite it here, 3 a to the negative 2 b to the 4th divided by 4 c to the 3rd z to the 0. Ask ourselves the questions. Is it going to move or is it going to stay? The 3 to the 1st and 4 to the 1st are going to stay where they are. A to the negative 2 is negative, it has to move down to the bottom. So I'm going to take this a to the negative 2, rewrite it down here. B to the 4th is positive, it's going to stay. C to the 3rd is positive, it's going to stay. Z to the 0 equals 1, and we don't write it at all. So this is our final answer. 3b to the 4th over 4a squared c to the 3rd. That would be our answer without writing with negative exponents. So those are rules for negative exponents, keeping in mind that whenever you move from numerator to denominator or the other way, then the number becomes positive on your exponent. That's the whole reason that we move it. So keep in mind, ask the question, does it have a negative exponent? If it's yes, it moves. If it's already positive, it stays.